Explorer 3 was an artificial satellite of the Earth, nearly identical to the first United States artificial satellite Explorer 1 in its design and mission. It was the second successful launch in the Explorer program. Mission. The satellite was launched from Cape Canaveral Air Force Station, Florida at 17 hours 31 minutes and 0 seconds UTC on March 26, 1958, by the Juno-I vehicle. The Juno-I had its origins in the United States Army's Project Orbiter in 1954. The project was cancelled in 1955, however, when the decision was made to proceed with Project Vanguard. Following the launch of the Soviet Sputnik 1 on October 4, 1957, Army Ballistic Missile Agency was directed to proceed with the launching of a satellite using the Jupiter-C, which had already been flight tested in nose-cone re-entry tests for the Jupiter IRBM. Working closely together, ABMA and JPL completed the job of modifying the Jupiter-C to the Juno-I and building the Explorer-I in 84 days. Spacecraft design. Explorer 3 was launched in conjunction with the International Geophysical Year by the U.S. Army and an eccentric orbit. The objective of the spacecraft was a continuation of experiments started with Explorer 1. The payload consisted of a cosmic ray counter and a micrometeorite detector. The Explorer 3 spacecraft was spin-stabilized and had an onboard tape recorder to provide a complete radiation history for each orbit. It was discovered soon after launch that the satellite was in a tumbling motion with a period of about 7 seconds. Explorer 3 decayed from orbit on June 27, 1958, after 93 days of operation. Mission results. The discovery of the Van Allen radiation belt by the Explorer satellites was considered to be one of the outstanding discoveries of the IGY. Explorer 3 was placed in an orbit with a perigee of 186 kilometers and an apogee of 2,799 kilometers, having a period of 115.7 minutes. Its total weight was 14.1 kilograms, of which 8.4 kilograms was instrumentation. The instrument section at the front end of the satellite and the empty scaled-down fourth-stage rocket casing orbited as a single unit, spinning around its long axis at 750 revolutions per minute. Instrumentation consisted of a cosmic ray detection package and a ring of micrometeorite erosion gauges. The Explorer 3 spacecraft was spin-stabilized and had an onboard tape recorder to provide a complete radiation history for each orbit. Data from these instruments was transmitted to the ground by a 60 mW transmitter operating on 108.03 MHz and a 10 mW transmitter operating on 108.00 MHz. Transmitting antennas consisted of two fiberglass slot antennas in the body of the satellite itself and four flexible whips forming a turnstile antenna. The rotation of the satellite about its long axis kept the flexible whips extended. The external skin of the instrument section was painted in alternate strips of white and dark green to provide passive temperature control of the satellite. The proportions of the light and dark strips were determined by studies of shadow-sunlight intervals based on firing time, trajectory, orbit, and inclination. Electrical power was provided by Mallory-type room mercury cells that made up approximately 40% of the payload weight. These provided power that operated the high-power transmitter for 31 days and the low-power transmitter for 105 days. Because of the limited space available and the requirements for low weight, the Explorer 3 instrumentation was designed and built with simplicity and high reliability in mind. It was completely successful. Explorer 3 decayed from orbit on June 27, 1958, after 93 days of operation. A replica of the spacecraft is currently located in the Smithsonian Institution's National Air and Space Museum Milestones of Flight Gallery.